All right. So my name is Marisol Barrero. I am the global ergonomics manager for Amazon Web Services. So I just wanted to start out by really saying thank you to Brain Exchange and Jeff Friedman and company for 6 years. So I was doing the math earlier, and I was like, "Wow, I this is my sixth conference, and this is the fifth time that I have spoken in some capacity. So thank you to Jeff for letting me blab in a different capacity each year. So thanks so much. And really, this presentation regarding the role of wearables in ergonomics, I'm not so much wearing my AWS hat, I'm wearing a few other hats. So, first of all, as a certified professional ergonomist and kind of seeing the impact of all these different technologies in the area and the injuries that go along with that. And then also from automotive exoskeleton group perspective, which I co-founded back in 2018. It's a community that is really for sharing exoskeleton related information. So it's a community of producers and users that are sharing info regularly for the advancement of that technology. And then I'm also the director of workplace safety applications for the Wearable Robotics Association. Again, same purpose, a little bit more general for, sensors, exoskeletons, XR, and such. So I just wanted to give you that background before we get started. So I'm going to start this off as just a little primer in terms of what ergonomics is as compared to general safety. I know some of you know, but because I have been coming here the last 6 years, I know there's been general talk about safety and sprinkled with a little bit of ergonomics here and there. But I wanted to kind of give you that background for some of the non ergonomics professionals out there. So this is sort of like your Ergo 101 in a way. So ergonomics essentially means the laws of work. So it's a science of fitting the job to the workers to ensure that it is within their natural capabilities. So that's a lot, but basically, what we're doing is we're really looking at things from more of an engineering standpoint, trying to tease out the physical risk factors that are contributing to injuries. So we're looking to fit people in jobs, people of different stature. So, short people, really tall people, people with big hands, people with small hands, all operating the same buttons, people with short arms, long arms, all maybe horizontally reaching for the same objects. And a lot of times we're not capable of adjustability. So we can't build in adjustability. A lot of times we're building equipment that is going to be used globally, right? So it's going to be used in Japan, it's going to be used in Sweden, it's going to be used in the US with maybe very different anthropometrics, right? People of different sizes. So how do we do that, right? So it's definitely quite a challenge. I will say that ergonomics is not there's a kind of misnomer out there regarding, stretching programs, wellness initiatives, things of those, that nature. They're all great programs. They're great initiatives. They're very complementary, but ergonomics is more about sort of the physical realm and really making sure that things are ideally designed properly to begin with. So, WMSDs, those are work related musculoskeletal disorders. And I'll just say WMSDs because it's a very long name. But essentially, those are your ergonomics related injuries, and they might be known as different terms, your repetitive stress injuries, et cetera, et cetera. But essentially, they are disorders of the muscles, nerves, tendons, ligaments, joints, cartilage, spinal discs. So they occur over an extended period of time. So it's sort of like you're having too many physical risk factors coming at you. Your body doesn't have time to heal. So sometimes even the smallest thing can kind of make that trauma bucket sort of like flows over, and finally you actually feel something. So they're very different from the more acute injuries, your contusions, your trips and falls, not to make them any less serious, but again, they're very different, and I'll share a few points as to how they're different in just a little bit. And some examples, back strain, carpal tunnel syndrome, tendonitis, etc. So I think back pain is a very common one. So I'm pretty sure most people here have, at one point or another in their lives had some type of MSD, whether it's work related or not. So, how do they form? So, hopefully, you can see that from back there, but essentially, it's a multifactorial model. So, and this has been put together by the National Institute for Occupational Safety and Health. So, collecting information from studies for years and years and years. So, you've got several different areas to focus on, right? So, you've got your personal factors, which are things like your age, your gender, just your predisposition, your genetics, quite frankly, right? And you couple those with the physical risk factors, right? And your physical risk factors are going to be the main ones are repetition, duration, posture, and force. The more of those that you have, the higher risk a certain job is of causing a WMSD. And then there's some aggravating factors as well, such as vibration, contact stress, etc. So those kind of flow through a gate of psychosocial factors, as we term them. So those are things, those are sort of the, stress, um, social support, perceived control, job satisfaction, etc. And then all those work together to cause an MSD or not cause an MSD. So if you've got, two identical twins, you got Bob and Charlie working the same job, exposed to the same physical risk factors, but Bob has a better support structure, gets along better with his coworkers, et cetera, has more perceived control in his job. So Bob is possibly less likely, according to theory, to actually develop an MSD. So that's kind of your comprehensive system. So WMSDs far too rampant. So this is information from BLS, so the Bureau of Labor Statistics, and we have about 300,000 WMSDs per year in the US just from the private sector. So that's actually going to be, higher, probably in the 500,000 area once you factor in other areas. And they make a really big impact. So, median days away from work about 10 or so, which is quite large. And I always say when somebody has a WMSD, so everybody else in the family almost has an MSD. So I've definitely been there. I've had, you know, back issues, neck issues over the years, and it seems like it impacts the entire family, right? So it's like there are people helping you do things that you normally do. Everybody gets involved, right? So it makes a big impact to people, not just the person with the injury or illness or condition, but way beyond that. So really big impact to lives. WMSDs cost 4 times as much as acute injuries. And I used to work for an insurance company, so access to workers' comp data. When I went through the injuries and all the medical costs and medical indemnity, et cetera, it never fails pretty much that I shouldn't say never, I almost never fails. Usually the MSDs are about, 3 to 5 times as much as the acute injuries. And they also require more recovery time. So, compared to the acute injuries, you are away from work 40% more time. So again, they're really the ones that, not to belittle the other ones. Of course, no one wants to get a, finger amputation or anything like that, of course. But again, these are very significant impacts to people's lives type of injuries. So that is why I focus my energy so much on, the wearables, particularly, exoskeletons and sensors and XR, because I really see their future and I really see that they can make such an incredible impact to ergonomics to reduce the chance of MSDs. So I think they're really just, innovative game changers, et cetera. As an ergonomist, early on I was looking at, physical risk factors and all that. I actually worked for NIOSH for a couple of years and all that, but now really I kind of funnel a lot of my energy, not all my energy, I have to reserve a little bit for ergo at AWS, but a lot of it into this channel because I really see the long-term potential. So the ones I'm going to talk about today are exoskeleton sensors and XR, how they can really impact MSDs and ergonomics. So first one, this is really near and dear to my heart because I started with this back in 2016. So before AWS, I worked for Toyota Motor North America for 15 years. And back in 2016, I started dabbling with the exoskeleton. So this really kind of paved my path for other technologies. And I started learning about other things through this path. So again, this was sort of my baby in a way. So exoskeletons, you guys probably all know, but just in case, so I always like to kind of start out basic. So it's a wearable device that augments, enables, assists, and or enhances physical activity through mechanical interaction with the body. So this image you see there is from the exoskeleton report. I highly recommend it if you're not familiar with that channel. It is a wonderful news source that is all exoskeleton related. So exoskeletonreport.com. They keep, up to date information in terms of all devices, all the research, all the news, etc. So there's many different types of exoskeletons. So there's some industrial or occupational, and then of course there's some medical, military, and consumer. So the types right now, so you've got some passive exoskeletons, which basically mean they're non-powered. And then you've got some powered systems that, have a battery or some other power source. And you have all sorts of industrial applications. You've got, shoulder, back, legs, hands. You see some photos there of all the different types of devices that I have either implemented or trialed at one point or another at Toyota, and now working on some at AWS as well. So producers, there are many of them. They tend to be startups. They're sprinkled all across the world. So the field is really growing in Europe, but they tend to be a one or two product type of company. But again, they're growing quite a bit. So this number used to be, in the single digits, and then really low double digits, just a few years ago. And the field is really expanding. And they're in the news quite a bit. So you see a lot of information in the news, from the technology news all the way through the regular news that you put on at night. This is what the general public typically envisions, quite frankly. So maybe some of you that are not exposed to exoskeletons, but certainly anybody beyond the walls of this conference, when they think of an exoskeleton and you say that word, they think of something like Iron Man, something very sophisticated that can wildly increase your strength. But the reality is that, they've really started out as very simple devices, such as the one seen here, which is a shoulder exoskeleton. This is a levitate airframe, and it's being used to support overhead work in assembling a vehicle. The concept of human augmentation and being able to do more than we physically normally can has been around forever. So if you kind of dig through all the patents and such, the first one goes back to 1910, when H.M. Powers had this suit, had this harness. And ironically, it looks like a lot of the devices today that are coming on the market. So when I look at it, I think of the HeroWear Apex, quite frankly. So it kind of looks like the exosuits that are emerging, if any of you are familiar with that one. And then again, they've been popularized through time. So General Electric back in 1965 had this wild concept that was called the Hardyman. So it was basically meant to help the user lift incredible amounts of weight. It didn't work, but still, it was kind of like in the popular realm. And it's just kind of interesting how these things get funneled time and time again. And it kind of looks like the Sarco's XO. If any of you are familiar with that, it kind of reminds me of that one today. Then there was a lot of experimentation in the military. So in the early 2000s, you had, Raytheon coming out with their XOS, and you had Lockheed Martin looking at the very appropriately titled Hulk, right? The Human Universal Load Carrier. So military is still experimenting with that today. So I know we've got the Army as part of our automotive exoskeleton group. It's gone way beyond automotive, as you can tell. But they're still experimenting with that because soldiers have very significant demands in the field. So they need to carry devices. They need to walk very great distances. They need to walk upstairs. Apparently, that is seen as the future of warfare, going up steps in urban environments with lots of gear. So they have a real need for that. But it was really 2016, and this is not from a history book. This is from my own personal experience, when really the automotive industry were really early adopters in terms of looking at what was out there. It was the first time that you had really robust enough, simple devices to bring into manufacturing. So I really termed 2016 as the expansion of occupational exoskeletons. And this was it. This is the Exobionics. This was the first company that I had on site at Toyota. So they came to our Texas plant, and they were the very first one with a model that was usable at the time. And since then, it's just really been growing. You can label them many different things. So here's the hierarchy of control from NIOSH. So some people call them PPE, or personal protective equipment. Some companies call them engineering controls, some call them tools. But again, it's what I always say is call them what you need to call them so that they really meet the needs of your culture. So, and that's really all there is to it. But there's always a lot of debate in this area as to what to call them. So the studies. So what are they saying? There's a lot of talk here about, are they good? Are they not good? But I always go to the research, of course, to guide me. So most of the studies so far, and by the way, they've been exponentially growing. So the number of studies on exoskeletons have skyrocketed in the past 5 years. So like there were one or two per year in the beginning, and now there's hundreds. So they're particularly looking at muscle fatigue reduction and ratings of perceived exertion. They are mostly lab-based studies with few field studies coming into play. Their general findings. So this is a really great article if you're all interested. In 2019, a couple of researchers from France, they reviewed the publications, 30 different publications on exoskeletons and with regards to upper limb and back exos. And what they found is that there's clear potential in limiting local muscular demand. So that is very clear, right? So they are reducing muscle fatigue, essentially. But again, the jury's still out in a lot of different areas, right? Such as, the long-term impact. What are they doing to like coordination patterns, et cetera? Are they activating different muscles that weren't previously activated with using the devices? But again, it's very early on in terms of noting the value of the devices. There was a recent Ford study that is again has emerged as one of the few field studies that are really good out there. So Virginia Tech and Marty Smets from Ford engaged in this study. So 18-month-long longitudinal study across 9 global Ford facilities. And the main findings, I think, they were pretty positive. So the workers did find value, perceived reduction in fatigue for wearing the exoskeletons, and there were less medical visits involved in those that wore the exoskeletons as compared to those that did not, the control group. So I think some good items emerging from the field studies. The road ahead. So this is another really great article if you're interested in this area. So CREA et al. 2021, relatively recent. So this is out of Italy, but it's really a large European panel of researchers. They've put together all this information, reviewed studies, and really are noting the path ahead. So they're basically saying this is going to be the path forward. So we're having the lab studies. Those are being done. Those have been done. At the same time, we have the standards coming in. So ASTM F48 is emerging. You're having tools, ergonomics assessment tools that can actually look at before and after with an exoskeleton, such as the ExoLift tool that was just published this year. But now what you really need are those field studies and really long-term occupational use to really guide the path forward. So again, really good article if you want to get some of their insights with the future for these devices. So again, huge possible impacts well outside the occupational area. So fatigue reduction, worker morale, certainly less MSDs. But I think one area that's kind of untapped is, opening the workplace to people with disabilities, pre-existing conditions, the elderly, right? Those that can't grip that much, that might actually be able to wear the BioServo Iron Hand, and all of a sudden they can grip better than they used to before. So return to work, possibly that's being tapped into a little bit. So getting people back to work quicker, because that's always from an occupational rehabilitation standpoint, the quicker you are doing stuff, the better it is for your long-term outlook. So those are all huge potential areas of benefit. Now, they do certainly have a lot of negatives. Certainly, I've just listed a few here. There is the potential that more difficult jobs could be created with really the wrong mindset. There could be less reliance on more effective controls, right? So less reliance on elimination, substitution, et cetera, that could happen in the wrong hands. Workers needing to wear more and more, such as the image I've got here. Like when is enough, right? Now you've got an exoskeleton, you've got the sensors, you've got all these different things happening. Also, an exoskeleton program could take significant resources. So wearable sensors, how many minutes do I have? 5 minutes? Oh, okay. Well, yeah, not good. So I'm going to go through these pretty quickly, but I think you guys all know wearable sensors. So you've got some IMUs and you've got some biosensors collecting information. So between those two, you can collect a lot of motion data. You can collect things like fatigue, et cetera. And then there's some ambient sensors that can actually collect things like, some basic air sampling. They can collect noise, et cetera. So those are all kind of coming together. Some of them give you feedback, right? Visual feedback, haptic feedback, et cetera. And there's a growing list in this area. So I'm not going to go through them at all here, but you can kind of see the growing list. The one that I know the best is the Strongarm. Back then it was called the Fuse sensor, and now it's called the SafeWork sensor. But essentially it's a sensor that collects a lot of trunk movement data and then bottles it up into a safety score that is very easy for a worker to understand. So it's a, 0 to 100. The higher it is, the better you did lifting. And it can give you feedback in terms of if you're engaging in really high risk postures. So we did a trial with this at Toyota, and it had really great results, quite frankly, in my opinion. So 2 months, 120 workers. It reduced the time to complete these assessments by 95% because we had a really long tool to actually collect this information. We had 83% of the workers improve their lifting techniques through the haptics feedback. And overall, we had 15% risk reduction as measured by the device. So again, really amazing in my opinion. So a lot of huge impacts with this technology, a lot of positives, some negatives for sure. So I'll just cover really the last two here because I'm a little bit short on time. But really, this is the first time that an assessment tool can also be a control. So this really introduces a new paradigm in safety for me. So I've never known an assessment tool that can also be a control itself. So this is quite new to give that feedback to the worker to be able to self-correct and possibly be coached to do a little bit better. So the image that you see here, which I forgot to note, is a single job at Toyota with many different people going through that job. Historically, we would have assessed that one job and have been done with it, right? Because we don't have resources to look at every single person on that job, and very few companies do, right? So here you see an image of all these different folks going through the job, and they're actually doing it very different ways. People are moving differently, they're exposed to different risk. So how beautiful is this if we actually find the people that need a little bit more support and we coach them a little bit more closely to be able to do the job properly. So, and of course, there can be some negatives with sensors, so they're body worn, right? So whenever there's a wearable, well, that's bad. Nobody wants to wear anything. Of course, there's privacy concerns, et cetera. The haptics could actually, when they're removed, the good impact could actually go away, right? So that's just positive reinforcement, operant conditioning. It could actually go away and really negate all the good impact you've had early on. Just cover this super quickly because again, out of time, but key XR benefits. So I think I really see them: early design reviews, enhanced training, and seamless instruction. So Ryan Porto from General Motors, who's going after me today, has a whole presentation about the benefits of VR in early design. So really the goal in ergonomics is to impact good design. So he'll cover that. And then really for training, I think there's a huge, huge benefit that can come along. So this is Edgar Dale's Cone of Learning, and it's just classic education theory. And really what it says is that we remember, and this is going to be obvious to most people, right? We remember what we do, what we're really engaged with. Most of the training today, right? So we've gone from instructor led to e-learnings, right? So now we're bombarded with like hundreds of e-learnings every year, especially in my company. But again, how do we make them more interactive, more memorable for people to actually remember? So there's, possibilities to create safely high-risk simulations, such as for, fall risk protection, for lockout, control of hazardous energy, et cetera. But for ergonomics training, it can be huge, right? So one of the issues in ergonomics is people applying too much force, installing things, for example. So a very classic one in manufacturing was power tool usage. So instead of letting the power tool do the work for you and installing the fastener, people would grip on the power tool and they wouldn't let the power tool do its own thing, right? So that biofeedback training with the use of all these different accessories that are emerging is going to be really huge. So a lot of these different items, I haven't gotten a chance to see the expo hall. Maybe they're there today, but there's the VR glove that's adding tactile feedback. There's the Tesla suit that is going to make you feel things feel lots of different things as you go through VR training. That's really going to help the situation. So I'll cover these. So I did want to mention this. So VR and safety culture enhancement. So we don't talk about this one nearly enough, but I think VR can really help us quite a bit in terms of resolving difficult issues because nobody wants to be the safety guy or the safety gal who actually goes into a place and tells somebody else that they're not using their PPE, that they're not behaving safely. So having a very safe zone that is VR enabled to have these practices and conversations in can really assist our safety culture. So I'll move really quickly on this because I know we're low. So I just wanted to end on some positives and negatives. So again, super memorable. We all know that. Negatives, head worn, fit issues, distractions, over reliance on technology, removal from reality. So these things are real, and these things are the things that we have to really be aware of when we implement the technology. Let me go through this quickly. So, diffusion of innovation. So, I wanted to end actually on two more slides because I think we've noted time and time again so far today that these technologies are not out there yet, right? It's a very small niche of people that actually know this stuff. So, we haven't quite crossed over the tipping point to make these mainstream. So, what I'm asking you guys, right? So, the ones that are producers, please do these and keep these things in mind. So, good product alone is not enough. You have to think outside of your product, really support the organizations, be flexible, be open, listen, and be aware that your wearable is not the only one out there. So, how do we integrate all of this together? How do we have a really good wearables ecosystem? I talked about this in the previous session, but how do you all work together to make sure you have a common vision and not just competing against each other, getting market value? So please keep that in mind. And the last bit to users, please share, collaborate, share your successes and your failures. They're both important to note. And really don't just try things. So just because, we implemented exoskeletons at Toyota and called them PPE and made them required, this may not work in your organization because you have a very different safety culture than the other organization. So really just listen, adapt, and talk to each other. There really should be no secrets in safety. That's usually my motto. Um, I'll just end on this. So on behalf of WERA, so again, if you're interested in the topic, so WERA 2023 will be happening in April of next year in conjunction with Applied Ergonomics Conference. And then there's also WERA Europe, depending where you're located, to be able to continue the conversation. So thank you. Sorry, I was a little fast there at the end, but that's basically my presentation. Thanks. So I imagine we don't have any time for questions. So you can grab me after if you have any questions. So thank you.